Write the quadratic function in intercept form and give the function zeros. Guys, I'm going to let you in on a little secret. This is the same thing we were just doing. Y equals this stuff is the same as we're going to find the zeros by setting it equal to 0. We're seeing when the y's are 0. So the right side, factors of 12, you got 1 and 12, you got 2 and 6, you got 3 and 4, which set can add up to 7, 3 and 4, x plus 3, x plus 4, and then let's get our answers. It says x plus 3, so x could equal negative 3, and x plus 4, x would equal negative 4. These are the two zeros, which again, this is like if you had a parabola, here would be the two spots where it would cross your x-axis. So the parabola might look something like this. It's just a sketch for it. I don't know what it would actually look like. Let's try it again. Let's find some zeros. Okay, so if we set this equal to 0, this one you could factor, which we'll do it with factoring, but if Mr. Plant was doing this all by himself, I would just add 4 and take the 2 square roots of 4. We're not there right now. We're not doing that. Guys, that's not how we're going to do it on this one. I can square root both of those, and there's a minus in between. So remember, when you factor like that, you square root them both, put one with a plus, one with a minus. Square root of x squared is x. Square root of 4 is 2. It says x plus 2, so that means x could equal negative 2. It says x minus 2, so x could equal positive 2. Again, picture this as a graph. They're intersecting the x-axis at negative 2 and positive 2. So the graph would look something like that. You've already done the graphing. Now we're just doing the factoring part of it. A little bit easier than graphing. IMO. Oh, that was too much. Just too much. Okay. X squared minus 3x equals 0. Do they have a common factor? Yup. They both have an x. X times x is x squared, and x times negative 3 is negative 3x. Now, there are two parts of the equation we're going to set up here. X minus 3 equals 0, fine. So x would equal positive 3. But also, this x could have its own equation where it would equal 0. And there's really nothing to solve there. X equals 0. Great, right? Because 0 times whatever the other parentheses would be still comes out to 0. So anytime you have an x all out by itself out there, or even if it was 5x, then that x could equal 0. If you sub in either of those values into the original equation, they both work. All right, last one. We're going to factor out the negative sign. So inside, we're going to make it positive x squared, negative 16x, and positive 64. Now, remember that negative sign doesn't really make a difference here. We could divide by negative 1 if we really wanted. I can square root x squared, and I can square root 64. Square root of x squared is x. Square root of 64 is 8. So let's see if it's one of these perfect square ones. If I multiply those two together, x times negative 8 is negative 8x, times 2 is negative 16x. So we only need to set up one equation, the x minus 8 equals 0, which we then just add 8 to it, and you get x equals positive 8. There's only one answer, because if there were two sets of parentheses, it would be x minus 8, x minus 8. They both come out to positive 8. So we only write it one time, which if that was a graph, x equals 8 would be here, and the graph would be like that. So it would intersect